Hello, this is video 5 for Chapter 9, STA2023 Statistical Methods. Here we're going to be looking at two separate groups, two independent samples. So the conditions are going to be that be random, independent from each other. They have to be two separate independent groups. And again, we want to make sure that we have at least 25 to make sure they're normal. Notice because we have two groups, the formulas are larger. So we have x bar 1, x bar 2, two groups. Standard deviation 1, standard deviation 2. Be very careful with this formula. It takes practice for the interval. So the best thing to do is really just get into an example. Again, all the calculator steps are here when you do a confidence interval, but with this first example, we'll go through it all. But your t will be x bar 1 minus x bar 2. Notice it says minus 0 because we've seen the difference between the two groups compared to no difference. So I won't put minus 0 because it doesn't change anything, but that's why the minus 0 is there. And your SE formula again is longer because we have two groups. And be careful, standard deviation squared divided by the first n plus the second standard deviation squared divided by the second n. This will take a little practice. So our first example is researchers studying people's sense of smell devise a measure for smelling ability. If you score high on the scale, you can detect smells better than others. Although it was not a goal of the study, we can use the data collected by these researchers to determine whether women or men differ in their ability to detect smells. The fact that the researchers felt it was important to record gender of the study participants suggests that there may be some reason to think that sense might vary based on gender. For this example, we compare men and women whose sense of smell was measured while they were lying down. And here are the data. So in this case, we have statistics. We don't have all 18 men and all 18 women, but we do have the statistics for us. And we're going to go ahead and use this to find our information. So again, we have two separate groups. Now just be careful which one you put first. I'm going to put women first, and then we'll make sure that's consistent, so women will always be first. So since we have two groups, we're going to set the two groups equal to each other. In the problem, we're going to apply that they wanted not equal to, so you can practice that. So the average for women is equal to the average of men. That will be our HO. The average smelling ability for women is equal to the average smelling ability for men. And then the HA is the average smelling ability for women is not equal to the average smelling ability for men. We're going to check our conditions. They're two separate groups. Men and women are two separate groups, independent from each other. Technically, there should be 25 in each group. We only have 18, but we'll go ahead and assume it's close. But you want to have a larger sample if possible. And you can, when you check the population, you can either say all people and say 10 times 18 plus 18, which is 360, or you can do them separately. All women, is that greater than 10 times 18, which is 180? And all men, is that greater than 10 times 18, which is 180? And they're both true. Now, here's the work. Again, be very careful when you put in your SE. It's the square root of the first standard deviation, 2.7295 squared divided by 18, plus 3.3583 squared divided by 18, all under the radical. Be careful. Type it all in. It takes a little bit of practice, but you know you're right if you get 1.02. 1.02. Then we're going to take the first group, which we said was women, 11.125, minus the second group, 10.0694 divided by your SE of 1.02, which gives us a T of 1.04. Now remember, we're trying to see is there a difference or not. The claim is that they're the same. Men and women smell the same. We think that they're different. Now when we go to the table to find our T star, and we've done this before, so I'm not going to do it now. When you go to the table, it's 95% is your confidence interval, and then n minus 1. Now, you could put the two groups together, and there's a more complicated formula to find the exact degrees of freedom, but because it's an estimate anyways, and we already have enough complicated formulas, an estimate would be the smaller n minus 1. The smaller n minus 1, since they're both 18, we just do 18 minus 1, which is 17, which gives us 2.11. Again, this is just an estimate. Picture-wise, if we compare the critical values, 1.04 would be here, but we're doing not equal to, so we have to have a negative 1.04 shaded both sides. That will be our p-value. 2.11 would be to the right and to the left of the t's, and then that could be a picture of our alphas. Notice our p-value, the area, is much larger than our alpha. But we can find the p-value in the calculator. So to find the p-value in the calculator, we go to Stat, Test. This time we're doing two sample t-test, number 4, two sample t-test. We have the stats, and remember we put women first, so the women was 11.1 STA2023 The women's standard deviation was 2.7295, and there were 18. The men were 10.0694, and the standard deviation was 3.3583, and there were 18. Now the groups are the same, but they don't have to be. We're saying not equal to. And pooled, yes or no, means do you want to pool the data together? And the answer is no. We're going to keep it no, keep them separate. And then if we go to draw, we will get that same picture that we drew. And we should get a t close to it. Maybe a little off because of the rounding, and especially we rounded the degrees of freedom. So it'll be a little off, but it should be pretty close. And this gives us the picture. Remember, it's shading both sides because we're doing not equal to. It's shading both sides because we're doing not equal to. We get our t of 1.03, very close to 1.04, and there's your p-value, 0.3083. 0.3083. So we compare our p-value, 0.3083, to our alpha, 0.05. Our p-value is not smaller than alpha, so we should be really good at our conclusions now. We do not reject HO. There is not statistically significant evidence to reject HO because of our p-value. We conclude that the average smelling ability for women is not different than the average smelling ability for men. So basically what we're saying is the HO is that they're the same. We try to say they're not the same, and they're not different from each other. They're not different from each other. So remember, when we do our confidence interval, if the women had a better smelling ability than men, we'd expect 2 positives. If the women had a lower smelling ability, we'd expect 2 negatives. In this case, they're not different, so we're expecting a negative and a positive. Could be lower, could be higher. So when we do our confidence interval, it's x bar 1, 11.125, minus x bar 2, 10.0694, plus or minus our t star, we're using 211, again it's just an estimate, times our SE, 1.02, which gives us a negative 1.0966 and positive 3.2078. So when I explain the negative means lower, positive means higher. So we are 95% confident the average smelling ability for women is 1.0966 lower to 3.2078 higher than the smelling ability of men. Basically, women could be lower or higher. There's really no difference. And in the calculator, we go to stat, test, and we go to 2 sample t interval. Notice all the numbers are in there for us. We're under stats, have all the numbers correct. The confidence interval was 95%. Pooled is still no. We go to calculate. There's your negative 1.02. It's pretty close to negative 1.09. It's off by 0.07. 3.20, 3.13. Again, it's off by 0.07. But if you notice the degrees of freedom is different, we used an estimate for that. Thank you.